Hi, it's your Pieman Subhodeep Sarkar back again, and in this video, we will be looking into how we can create fork bombs using Python and Bash. Now, if you do not understand what forking is or what fork bombs are, do not worry, we will be starting from the very basics. Before starting, I'd like to say that this video is solely for educational purpose, so do not misuse this knowledge in somewhere else where you are not allowed to use the computers. So let's begin. Alright, so before jumping to the code directly, let's learn the theory portion. We must understand what a process is. Let's say we have a program installed in our computer, let's say Microsoft Word. We all are familiar with this one, right? This is a program, not a process. Alright. Why am I calling it a program? Because it is not the actual entity that is running. It is what we double click and then run, right? So it exists only in hard disk or might be SSD or some other permanent storage portion. All right, it does not stay inside the RAM. Okay, so it is not what actually runs. It is a passive entity. It is a bunch of code. All right, understand this like this. It is a bunch of instructions, or you can say code compiled together. All right, it is sitting inside your hard disk or memory, your SSD. Yeah, so it contains instructions. Instructions, yeah. But when we double click it and run it, so when we run it, it becomes a process. Okay, so now this process is what actually is running and executing the instructions which was present inside this program. So this one exists in the RAM or the main memory, you can say, and this one is active. So this is what is actually running on the CPU. And yeah, that is what a process is. Now the process has a structure inside the RAM. The structure looks something like this. It has mainly four portions. The first portion is called the stack, then heap, then the data section, and finally the text section. Now let's understand in brief what all of these means. This stack portion stores all the temporary values like the local variables inside a function, the function calls, the return statements, and everything. So this is handled by the stack, the temporary data. The heap is used for dynamically allocating the space. Let's say you are creating a linked list in runtime, or you are maybe using Python lists or Python dictionaries. For that purpose, the data size is not fixed. Heap is used to allocate more memory. Then comes the data section. The data section holds the global variables. And finally comes the text section, which contains PC, that is program counter, which has the address of the next instruction to be executed. So all the instructions are present inside the RAM, and this PC contains the address of the next instruction that is to be executed, and some other register values inside the CPU. All right. So this is what a process looks like inside the RAM. Okay, inside the RAM. Now let's go into what forking is. So basically, fork is a system call which creates child processes. Okay, so what I mean by this is that let's say you are running MS Word and suddenly it calls a fork. So it has this structure, right? The stack, heap, data, and text. This will be copied and another Microsoft Word will be created with the exact same value. So whatever there is present inside this will be copied down to this, and this. So now there will be two processes running simultaneously. Yeah. Let's say you call fork once again. So fork is basically creating child processes. Now you already have two processes. When I call fork once again, what will happen? See, this guy over here will create another child. Here I go. All the things will be copied from here to here. And since this is also existing, this will once again create a child with the same values as of here. So all the contents will be copied. So now there are four processes, all right, of the same program. That is what fork does. Okay, so let's say you have called fork one times, it will create two processes. If you call fork two times, it will create four processes. If you fork three times, it will create eight processes, and so on. So in general, if you call fork n number of times, it will create 2 to the power of n number of processes. That is what fork does. If I keep on creating these processes and each one of them occupies some memory of the RAM and some processing power of the CPU, eventually my computer will run out of the memory as well as the CPU processing power, and finally it will crash, and there will be no way to recover but to shut it down entirely. So that's what a fork bomb does, and that is what we are going to create using Python and Bash. So to write the fork bomb, we must need an Unix based operating system like Mac or any distribution of Linux, or might be BSD, because fork is a system call that is only present for Unix based operating systems. It is not present in Windows or some other kind of operating system. However, in Windows you have the equivalent of spawn, which you can definitely try it out on your own. Alright, so now we are into the system. Now let me write a program to demonstrate how fork actually works. So let's write the program. Yeah. So here all you need to do is to import OS, because the fork is a system call. So you need the operating system module to interact with the operating system. Now let me print some random statements. Python is awesome. Sunday is holiday. Okay. Now we create a child process. So the parent will pause here. Okay. Once the parent pauses, the child will start executing from here, because the child is created from this line. It cannot go backwards. That's common sense. Now we can print hello world. Monday is work day. Right. So let's understand the order these statements will be executed. Follow my cursor. The parent will execute this line, then it will this execute this line, then this one, and then it will create a child and it will pause itself. Okay, so parent will pause here. Now the child will start executing from this line onwards. So that means the parent will be paused and the child will execute this line, and it finishes. Once it finishes, the parent once again resumes its execution. Now the parent will execute this line, and the program finishes. So the order of printing will be Python is awesome, Sunday is holiday by the parent, and then the parent pauses. Now the child prints hello world. Then the child also prints Monday is work day. Then the child finishes. Once the child terminates, the parent will start executing from here, and it will print hello world, Monday is work day. Now let's run this and see this in action. As you can see, so these two statements are printed by the parent. These two statements are printed by the child, and once the child is finished, the parent prints this one. So that's it. Now to create a fork bomb, all we need to do is to make some modification. So you need a while loop, and warning, this will crash your entire system. So create fork, so create a child infinitely, and that child has to execute some sort of code. Now once again you call the fork, and the child will now execute some other statement, and that's it. Our fork bomb is ready. Now to demonstrate you, let me just open the resource monitor So this is a resource monitor. Let me just reduce the latency a little bit. That's okay. You can see every process is taking some memory. Like for example, this genome shell is taking 233 megabytes. This one is taking 32 megabytes. So that's how, if I start the program, you will see that every process will take little bit of space and eventually our RAM will run out. So forkbomb.py, let's run this and goodbye computer. You can see it's taking some of memory over here, 5 MB, 5 MB each. And our computer has stopped responding, I guess. No, it is still responding. Okay, that's it. Computer has frozen. You can see all the memory has been used. The CPU resources has been used. The computer is no more responding. Icons are frozen. Everything is just frozen. Now I cannot even close this one. Okay, so if I try to close this one, you will get an error actually. After a little bit of struggle, I finally shut it down. And now let me show you the bash version of it, which is extremely easy. However, it is a little bit confusing. Let me just, all you need is just 14 characters, colon, parentheses, curly braces, and inside the curly braces there is colon, pipe, colon, ampersand, semicolon, colon. And that's it. Now let me explain you all of these weird symbols. The first symbol, which is colon, is basically a function, and the name of the function is a symbol, which is colon. And after every function, you have a list of parameters. You have none here. Okay. Then there is the function body. So from here to here is the function body. Inside the function body, you are calling the function once again. So this is recursion. This function outputs the data into itself, which is another recursion, and this ampersand is putting it into the background. Okay, so the user won't be able to see this, it will be in the background. Finally, we close the function body, and then this semicolon means the end of line. Finally, we call the function, and then there's infinite recursion. It will never stop. So now let me show you what happens by opening the resource manager. Okay, so now if I run this, the computer will be frozen once again. 3 2 1, here we go. So I have started running this one, and yeah, it's kind of frozen. Okay, so the computer has completely frozen. It's not responding anymore, as you can see. Yeah, we're pretty much dead. And I think this version is a little bit faster than the Python one. Here you can see resource temporarily unavailable. Retry, because the resource is not available. So let me just stop it and let's see. Okay, I cannot even stop things because, okay. All right. So this is our fog bomb. I hope you have liked the video, you have learned something new. And if you have really enjoyed this video, please share it with your friends, and happy learning. Thank you.